Welcome to homework.
Okay, so in each case, we're referring to pentanoic acid. Okay, and first we're going to react with sodium hydroxide. And this is just going to be a simple acid-base reaction. We're going to deprotonate and get the salt of the carboxylate. Right, O minus and A plus, right? But we'll generate water in the acid-base reaction, right? So it's just sort of a proton transfer to the OH to give water. That is not H2O plus. That's just neutral water. I don't know why I wrote plus there. Okay. Let's look next at sodium bicarbonate. Right? Same idea. Again, we have a base, right? We're just going to end up with the sodium salt of the carboxylate. And now we'll end up with a neutral carbonate. Right? Oh, I think I've made a mistake here. This should be a single hydrogen here. And then we should have 2 here for the neutral. Right? And that's because carbonate, if we consider the structure, the original one was sodium O minus that, and we've generated there's our H2CO3. Okay, that's just a little bit of an aside. Okay, we'll move on to thionyl chloride, SOCl2. Thionyl chloride will convert carboxylic acids into acid chlorides, like so. Okay. These are very reactive, so thionyl chloride will give us reactive carbonyls, which is kind of nice. Okay, phosphorus tribromide, same idea, but with it'll give us acid bromides, right? Again, nice reactive substrates. Okay, benzyl alcohol and sulfuric acid, right? So benzyl alcohol. Okay, and sulfuric acid. In acidic conditions with an alcohol, carboxylic acids will undergo Fischer esterification. That is, we'll move from having a carboxylic acid to an ester, basically using the rest of the alcohol will basically get incorporated into the ester, meaning instead of having OH here, we'll have O, and then in this case, it'll be benzyl. Okay, so. All right. Lithium aluminum hydride and then hydrolysis. Remember, lithium aluminum hydride is a reducing agent, and it will reduce a carboxylic acid into a primary alcohol. So rather than a double bond to oxygen here, we'll have a single bond to OH following the acidic workup or hydrolysis, right? And then we'll have 2 hydrogens here, right, which previously weren't there. Finally, we have phenylmagnesium bromide. Okay, so this is a Grignard reagent. I'll point something out here. It's essentially like we have a carbanion there with MgBr plus. Okay, this anion here is incredibly basic. If we react something that's incredibly basic with a carboxylic acid, what do you think that's going to do? We're going to deprotonate our carboxylic acid. Recall that Grignard reagents are basically pointless if we have proton sources, right? That is, it's not going to add to the carbonyl. All we're going to do is deprotonate and end up with benzene in this case, right? We're going to add a hydrogen here. That's all that's going to happen.